Have you ever looked up at the sky on a bright sunny day and wondered, why is the sky blue? It seems so simple, yet the reason behind it is one of the most fascinating stories in science. Let's start with sunlight. We often think of sunlight as being white, but in reality, it's made up of many colors. Red, orange, yellow, green, blue, indigo, and violet. You can see all of these colors when light passes through a prism, or when a rainbow appears after the rain. Each of these colors has a different wavelength. Red has the longest wavelength, and blue has a much shorter one. Now, as sunlight enters the Earth's atmosphere, it meets millions of tiny gas molecules, mostly nitrogen and oxygen. When sunlight collides with these particles, the light scatters in all directions. But here's the interesting part. Not all colors scatter equally. Shorter wavelengths, like blue and violet, scatter much more than longer wavelengths like red and yellow. This process is known as Rayleigh scattering, named after the British scientist Lord Rayleigh, who first explained it in the 19th century. So, if both blue and violet light scatter the most, you might ask, why isn't the sky violet instead of blue? That's a great question. The answer lies in how our eyes work. Our eyes are more sensitive to blue light than to violet light. And also, some of the violet light is absorbed by the upper atmosphere. So, what we mostly see when we look up is a beautiful blue sky. But the story doesn't end there. Have you noticed how the sky changes color during sunrise and sunset? At those times, the sun is lower in the sky, and sunlight has to travel through a thicker layer of atmosphere to reach our eyes. The shorter blue wavelengths get scattered out of our line of sight, leaving behind the longer wavelengths, reds, oranges, and pinks. That's why the sky glows with such warm, fiery colors in the early morning and late evening. In space, where there's no atmosphere to scatter light, the sky is completely black. Astronauts aboard the International Space Station see the sun shining brightly, but the space around it remains dark, because there are no air molecules to scatter the sunlight. So, the next time you step outside and see a clear blue sky, you're actually witnessing a bit of physics in action. Sunlight dancing with the air molecules of our atmosphere. It's a perfect example of how something we take for granted every day can reveal the incredible beauty and complexity of our natural world. In short, the sky is blue because of Rayleigh scattering, where the shorter, bluer wavelengths of sunlight are scattered in all directions by the gases in our atmosphere. Simple, elegant, and absolutely amazing, exclaims.